Thank you for giving me the opportunity to introduce you to the FAIRsFAIR Data Object Assessment Matrix and FAIRsFAIR, an automated FAIR data assessment tool. The work I present today was carried out in the context of the FAIRsFAIR project, and here under the umbrella of Task 4.5. The goal of this task was to pilot the FAIR assessment of research data from trustworthy data archives. And here we are focusing on research data which is observed, collected, or measured for scientific purposes. To achieve the goal of the task, we implemented two important components. The first component were the FAIRsFAIR assessment metrics, and the second component were actually two practical tools to perform FAIR assessment. Both components are addressing priority recommendation of the Turning FAIR into Reality report, a report which was published by the European Commission Expert Group on FAIR Data in 2018. In general, we followed a use case-based approach to scope our task for FAIR assessment, and therefore we identified and explored 8 different scenarios for assessments, which can be performed at different stages of the research data lifecycle as shown here. And each of these stages are, of course, involving different stakeholders and actors. Out of these 8 scenarios, we choose the 2 scenarios as priority use cases. One use case is about raising awareness of researchers for FAIR before they deposit their data in an appropriate data archive. And the tool we developed here is called FAIR-Aware. The other one is assessment on research data which already is archived in trustworthy data archives to evaluate their readiness for reuse, basically. And here we developed FAIRsFAIR to perform these assessments, and this is the tool which I'm going to show in detail in this talk. The metrics we specified to perform the practical assessment were defined based on prior work performed during the FAIRDAT and FAIRENOUGH projects, and of course were aligned with the RDA data maturity model as well as the World Data System RDA data fitness for use checklist. In an iterative process which involved several stakeholders, such a number of data publishers, international initiatives such as OGC, RDA, and WDS, as well as the EOSC, the European Open Science Cloud FAIR Working Group, we have defined 17 metrics which have been available for public comments, and I think they still are available for comments. So if you want to comment it, please visit the website at FAIRsFAIR EU. Based on the FAIRsFAIR metrics, we have defined several practical tests which can be implemented by an automated assessment tool. The approach here is hierarchical, which means each FAIR principle can have one or more metrics, and for each metric we have defined one or more practical tests. Each test is based on community best practices and standards. We have implemented all metrics and associated tests for the FAIRsFAIR tool, which is available as open source on GitHub. More information on the tool as well as the standard it's based on and so on is available on f-uji.net. FAIRsFAIR actually is a web service. Its REST API is based on the Open API specification and was implemented in Python using Swagger. This example here on the right side shows how an output of FAIRsFAIR looks like. The response is given in JSON format and includes information about, for example, pass-fail of the test, the score which was reached, and the output further specifies what FAIRsFAIR could identify in the metadata or data which justifies the result of the test. FAIRsFAIR further includes very verbose debug messages which can be used to reproduce the overall test flow. The REST API is, of course, designed for machine interaction primarily. This chart is summarizing the high-level flow of each FAIRsFAIR assessment. FAIRsFAIR is taking a PID or URI as input parameter to perform the assessment. Optionally, also an URI for an service endpoint can be given, such as Open Archives initiatives or Catalog for the web. FAIRsFAIR is trying then to identify metadata given, for example, at the landing page, and also is using other methods such as content negotiation or following typed links to collect additional metadata which are given potentially in other formats by the provider. FUJI is using the service endpoints to identify community-specific metadata, and it is also using third-party resources such as Read3Data to identify other capabilities of the metadata provider. FUJI is using then all the collected metadata to perform the subsequent assessment steps. In addition to the API and REST interface I showed before, we have also implemented now a web-based graphical user interface, which allows interested users to perform and analyze FAIR tests with FUJI in a human-friendly way without knowledge of API usage and JSON. The output of this tool includes a full test reports, which includes, for example, the debug messages and all the other items I mentioned before. It also has a graphical overview of the reached test result in terms of a percentage score and so on. This tool can be found on f-uji.net. FUJI was designed to improve the fairness of data and datasets. We therefore applied our metrics on 5 trustworthy pilot repositories. From each of these repositories, about 500 datasets have been assessed. And here we used an earlier version of our metrics and an early version of FUJI. Each pilot assessment was performed in combination with an in-depth face-to-face consulting process. We additionally manually checked selected datasets from each repository in order to verify FUJI results, as well as to identify potential improvements for each repository. These improvement suggestions were summarized in an assessment report, as shown here. Such a report contains comments and a recommendation for next steps for each metric. For example, here we suggested to improve the way how access levels can be expressed in metadata using schema.org. These assessment reports were discussed with data providers who in most cases took the opportunity to improve the fairness of their assets. To verify these improvements, we ran the assessment a second time. So this is showing the results of the first and the second tests, for example, for the Pangea repository where I work for. And the combination of the automated assessment and the face-to-face FAIR consulting resulted in almost all cases in significant improvements of the overall FAIR level. So you can, for example, see here that the accessibility improved after the first consulting round significantly from 0 to 100%. And also slight improvements can be noticed regarding the reusability of data, and also, for the other principles. So the lessons we learned during developing FUJI and setting up the FAIRsFAIR assessment metrics was that first, that automatized FAIR assessment of research data object actually is possible. So I think we could demonstrate that quite impressively. And second, that it is possible to support a very large and diverse community. So this was demonstrated by the diverse community of the 5 pilots, which came from various science domains. And in addition to these 5 pilots, we meanwhile also applied this methodology to archives from Chester, EOS Nordic, and Dataverse NL. The third lesson is that what we need to do is to use both assessments as well as associated tools to iterative improve these tools and metrics, and of course also the assessed archives in an iterative process. So this improvement process is ongoing for both archives as well as FUJI. And as a final remark, the main lesson we learned that the best use formula for FUJI and FAIR assessment is that this is to be used in a combination of FAIR assessment and intensive face-to-face FAIR consulting process. Thank you for your attention, and I would also like to remind you that FAIRsFAIR also developed other tools like FAIRsFAIR. So please use the opportunity to visit the FAIRsFAIR webpage to see more results of this great project. Thank you.